Good evening and welcome to the Q&A session 17 from the chapter of Oscillations. The topic is the calculation of the maximum acceleration of a particle which is executing simple harmonic motion. So based on this topic, I have selected one question for this session which was asked in the IIT-JEE main exam in the year 2025. So ये इसी साल का question है and the question is a particle is subjected to two simple harmonic motions as x1 is equal to root 7 sine 5t centimeter and x2 is equal to 2 under root 7 sine 5t plus pi by 3 centimeter. So here x क्या है? This is the displacement है and t is the time in seconds है. So हमें यहाँ पर maximum acceleration निकालना है particle का. चार options दिए गए हैं and we have to find the correct option. So in the session number 11 we have learned that if a particle is subjected to two simple harmonic motions having the same frequency, then in that case the amplitude, the resultant amplitude, say AR, of the resultant simple harmonic motion will be equal to A1 square plus A2 square plus 2 times A1 A2 cos phi, where phi is the phase difference between these two simple harmonic motion. Now the displacement equation of a simple harmonic motion is given by x is equal to a sine omega t plus phi. Now here phi is what? It is the initial phase of the simple harmonic motion. So from this equation we can say that the initial phase of the first simple harmonic motion is equal to 0. Let us say it is phi 1, so phi 1 is equal to 0, and for the second wave the initial phase, say phi 2, is equal to pi by 3. So the phase difference will be is equal to phi 2 minus phi 1. So the phase difference, so the phase difference will be equal to pi by 3 minus 0, which is equal to pi by 3. So the resultant amplitude of the resultant simple harmonic motion will be equal to, now A1 square, A1 is the amplitude of the first simple harmonic motion and A2 is the amplitude of the second simple harmonic motion. So this is equal to A1 is root 7 whole square, that is 7, and this will be equal to 2 root 7 whole square, this is equal to 7 to 4, 28, plus 2 A1 A2, so 2 into root 7 into 2 root 7, so this is equal to 4 into 7, that is equal to 28. 28 multiplied by cos phi. Here phi is what? It is the phase difference between these two simple harmonic motion. So this is equal to pi by 3, so cos pi by 3 will be equal to cos 60, which is equal to 1 by 2. So this is equal to 14. So I am getting this 7 plus 28 is equal to 35, 35 plus 14 is equal to 49. So the amplitude of the resultant simple harmonic motion is equal to 7. So if the so I can write the displacement equation of the resultant simple harmonic motion as x equal to 7 sine, this will be equal to 5t plus say pi dash, let us say. So this is the phase angle of the resultant simple harmonic motion, which I have taken it as phi dash. So what I will be doing here is I will be simply differentiating this equation twice in order to find the acceleration of this resultant simple harmonic motion. So if I differentiate it once, I will be getting dx upon dt. So this is equal to 7 into, I will be getting 7 into 35, 7 into 5, and this will become cos 5t plus phi dash. And if I differentiate dx upon dt again, so I will be getting d square x upon dt square, and this will be equal to minus 175, that is 35. I will be into 5, this is equal to minus 175, and I will be getting sine 5t plus phi dash, where phi dash is the phase angle of the resultant simple harmonic motion. So here I am not calculating this value of phi dash because it is not required. So the maximum acceleration क्या होगा? The maximum acceleration depends on the value of sine phi t plus phi dash. The maximum value of sine is equal to 1. So the maximum acceleration will be equal to 175 centimeter, and in meters it can be written as 175 into 10 to the power minus 2. So the correct option meter per second square, and this is in centimeter per second square. So the correct option here is A. So thank you very much for joining this session. Now in the next session we will be discussing a different type of a question from the same topic of simple harmonic motion. So till then, have a nice day. Bye.